Hi, I'm Erinn Rusnak from Alpha Structural.
I'm Erinn Clitheroe with Alpha Structural.
And we're here to answer your questions. We start out looking at many different things inside. We start looking inside the home, signs of sloping in the floors, doors out of square, windows out of square. It'll tell a tale. You'll see larger cracks that are coming out of corners, floors sloping into a particular side of the house or a center point. And you can kind of get an idea, and that tells you when you go underneath kind of where you're going to be looking, what you're going to be looking for. So cracks, that's one of the most common things I get asked, and you come out and you see almost every single time. So you got to realize in Southern California, we have earthquakes, we have rains, there's hillside, and there's a wide range of different things that can cause cracks. Cracks means there's been movement or some sort of shrinkage, and it can be from the most minor, benign, no problem, up to a red flag of magnitude. So when you are in a house and you go in and you see there's minor cracks, cracks themselves are cosmetic. It's a separation in the drywall or plaster or stucco, but there's movement. What we're looking for is what's caused the movement. Is it a large movement? Is it a major issue that's underlying it? So minor hairline cracks, no, let's put it this way. If we went into a mid-century home and saw no cracks, that's had no cosmetic repair, more often than not, I would be somewhat shocked. But if you go into a house and you see larger separations and, a wall has, separating from the floor system or part of the floor dips down, yeah, that's going to be something it's an indicator that I'm going to go, okay, what's causing this? We're going to go look at the foundation or some sort of, what is this framing support system that's there that's having some sort of separation? And it just is a tail for us to, or an indicator for us to look further into that tail and see what's causing it.
It all typically boils down to the ground movement. Even if we have a lot of expansive soil, clay-based soil in Los Angeles. So when you see cracks, a lot of times it's just that the ground is swelling and it's contracting, swelling and contracting over the years. Even in an area like the foothills here where my house is, I get hairline cracks in my drywall because as the ground gets wet and the season fluctuates, the weather fluctuates, a rainy season is going to cause the ground to have some sort of expansion or swelling manifestation. So when that ground dries, you're going to get movement. When the ground swells, you're going to get movement. So the cracks, it's really just a visual observation on how significant those cracks are, and that's going to determine whether or not we even propose any repairs.
One other thing too is, I'll go out sometimes and I'll look and you'll see a straight line down the middle of the ceiling. And you can tell it's right at the seam of two pieces of drywall. And more often than not, it was a poor taping and patching job that was done by someone in a hurry when they're doing a cosmetic repair, not a structural concern. It's literally just a separation in whatever paint or seal that's done over the drywall, right? But sometimes you have half a house settling, and as it settles, all the framing gets pulled. And as the framing gets pulled, things start to open up, and you'll start to notice a pattern as part of the house moves one direction. That's an indication that, yeah, there's a structural issue that we got to look deeper into and find out, is the foundation deep enough? Is there some lack of support in some part of the foundation? Kind of depends on the degree of movement that's happened already. So if we have smaller movement where the foundation's begun to settle and it's relatively healthy, the concrete being, you can deepen that foundation system into a more stable level or echelon of soil below, and to mitigate that settlement or minimize that future settlement. Drainage is crucial. You can't do anything if water's all coming at the home. Anything you're going to do, you got to get rid of the it's like pouring gasoline on a fire. You're not going to do that, and do some fix and expect it to be all magically better without getting rid of the water. That's going to be step zero. Step one would be, okay, let's deepen the foundation. If there's significant movement or the concrete's deteriorated because of the water intrusion or deterioration that's happened over time, you replace the foundation. Those are some of the very basic things that you can do. There's a lot of different things, but those would be just a couple examples.
When you waterproof from the inside, you are not tackling the source of the water. The water is coming from the exterior where the earth is touching the concrete. So usually what we've seen is people try to go the easy way, which is waterproof from the inside. And if it worked efficiently, we would suggest that as a solution. What we've seen though is that waterproofing membrane gets painted or applied to the interior surface of the concrete walls. That water is coming from the opposite direction. So water is still building up inside of those walls, behind those walls. And what it's doing is it's pressurizing at some point. If we have a heavy rain, there's going to be a lot of water pressure behind that wall. That water pressure is then going to bleed that water through the concrete walls, which concrete is porous in nature. So if you have a waterproofing system on the inside of those walls, ultimately what's going to happen is the water's still coming and it's still in the walls. And it's going to start bubbling the waterproofing system, and eventually it will break through that waterproofing system and continue to come in. If anything, that waterproofing membrane could also be trapping water inside of the walls and further deteriorating the concrete, the structure of the wall. So capturing the water from the exterior face of the wall is always your first option. Albeit it's the most expensive option because it usually requires quite a bit of excavation. But that's the way to, if you want a foolproof 100% system that's going to work, you got to go from the outside and put the waterproofing system there.
Okay, so there's a lot that goes into retaining walls, and a lot of it has to do with soil conditions and where you're located, steepness of hill, steepness of slope, type of soil. So it's not just a simple matter where someone can come out and go, you're gonna need this. There's actually quite a bit of testing that goes into the retaining wall design and engineering. So typically you're gonna need, first thing, a soils report from a geologist. The soils report's gonna tell us several key factors, two of which are how deep is the loose soil that needs to be penetrated, and then which will tell us essentially where bedrock is, and it's going to tell us the stability of the slope. It's going to tell us the stability and solidity of the rock. Earlier on in LA, there was a massive style of grading earthwork, moving earth, that changed significantly in the 60s. They used to move earth around, drive a tractor on it back and forth, thumbs up, build a house or build a wall. And they could have created a series of stepped homes, which they call cut fill lots, where they have retaining walls. You've seen this quite a bit, a retaining wall at the end, a retaining wall, and those foundation systems are founded in loose soils, and they start to lean over time. So the first thing is we need to find out how deep till good stuff. And once that is known, then we can design and engineer a foundation system that's going to embed into the stable soils, the bedrock, that won't move. But is it 2 feet or is it 32 feet deep? Those are very different price points and design points on a retaining wall. So we need to get more data. So if you have a retaining wall that's leaning, we can look at the soils information from a geological report. We do need to get a survey that shows property lines and topography so we can take that into consideration. And then we need to engineer the wall. So it's designed not only to support the soils behind it, but also seismic. We need to make sure that the thing's not going to fail in earth movements. And because we live in LA, there's a lot of other factors that go into, we're not just going to stack some blocks on top of each other and hope it stays, which is what we've had happen throughout time and why we have a lot of walls that have failed. The other factor too is the drainage behind a wall. Like Erinn was saying on the basement waterproofing, it's the same thing on a retaining wall. If you build up water behind a wall, it adds what's called hydrostatic pressure, and that can get very heavy. Water accumulating adds a lot of weight and pressure, and walls start to lean. So having proper drainage and sub-drainage in retaining walls is a requirement. It's not just hey, we think it's a good idea. It's actually something that needs to be in place. But older retaining walls didn't have that always. So you get a situation where these retaining walls that have functioned throughout time, and as as weather changes, as rain changes, as water increases, and we have atmospheric rivers, new terms, that are coming out. What it is it's as rains changed and seasons changed and water flows changed, we've noticed situations where areas that have gotten super saturated, that never have been super saturated, are now suddenly finding this situation. And we get a lot of calls where it's been fine for 30 years and now suddenly ... Well, things have changed significantly with regards to the water. So the water flow and this is all data and information that's provided in a geological report, but it's all things that need to go into consideration on how you design a wall that's going to last. So that's you would start by first having us come out and assess it. We'd coordinate with all other entities that would be needed, whether it's geological, survey, and we would perform the structural engineering and design the wall that would retain soils and not fail.
Yeah, we get a lot of questions too with the older walls that are visibly leaning, cracked, somewhat deteriorated, and it may or may not still have life left into it. So one of the biggest questions we get asked is, how long is my wall going to last? That's a very loaded question. It could fall overnight. It could last another 40 years. The warning signs on a wall like that are the visible rotation of a wall, right? If you see it leaning and separating, one side's flat, one side's leaning. I've seen them leaning up to 20 inches and they're still standing. But a 20-inch wall at a 45-degree angle, the next rainy season, the wall could topple over. It could be up in the Hollywood Hills close to a house. There aren't a ton of warning signs for a vertical wall that all of a sudden collapses overnight. The heavier the rain, the older the wall, the shallower the foundations, the more likely it is to have an imminent failure. So we've seen walls collapse. I've seen brand new walls collapse just because of poor construction on a hillside. So the safest thing to do is, if you see severe distress on a wall, is to, get a qualified contractor out there and assess it and possibly replace it. At Alpha Structural, we specialize in anything structural. We're a design, build, construction firm that does all the engineering in-house and the construction. If you're experiencing any distress to your home, such as cracked walls, cracked drywall, door frames that are out of square, feel free to give us a call. Thank you for watching. If you enjoy videos like this, like and subscribe for more.